Imagine a tiny glass dish sitting forgotten in a laboratory. Inside it, something strange is growing. A patch of mold has appeared. Around it, a clear circle has formed. The bacteria that once covered the dish have disappeared. To most people, it might look like a failed experiment. To Alexander Fleming, it was a question. And that question would change medicine forever. In 1928, Fleming was working at St. Mary's Hospital in London. He was studying bacteria called staphylococci, organisms that could cause serious infections. His laboratory was busy and imperfect, just like many working laboratories of the time. Glass dishes stood on tables. Notes and instruments were scattered around. Experiments were constantly being started, examined, and sometimes forgotten. Then Fleming left London for a short holiday. When he returned, he began looking through his old cultures. One dish caught his attention. Something had grown in it. There was mold. But the mold was not the interesting part. The interesting part was what surrounded it. A clear area had appeared around the mold. The bacteria were no longer growing there. Fleming leaned closer. He could have thrown the dish away. After all, it had been contaminated. Instead, he stopped and asked a simple question. Why were the bacteria disappearing? That question would eventually lead to penicillin. But the story of Fleming's discovery began long before that forgotten dish. Alexander Fleming was born in 1881 on a farm near Lochfield in Scotland. His childhood was surrounded by fields, animals, streams, and open countryside. Life was simple, and his family had limited money. His father died when Alexander was still young. Even so, Fleming continued his education. He was quiet, observant, and curious. He liked to understand how things worked rather than simply accept what he was told. As a young man, he moved to London and eventually studied medicine at St. Mary's Hospital Medical School. There, he found a field that matched his personality. Bacteriology. The world of invisible organisms fascinated him. Under a microscope, a drop of liquid could become a strange landscape filled with tiny forms of life. Some bacteria were harmless. Others could cause terrible disease. At the beginning of the 20th century, doctors were learning more about bacteria, but they still had a major problem. They could identify many dangerous organisms. They could sometimes prevent infection. But killing harmful bacteria inside a human body without damaging the patient was much harder. An infection could turn a small injury into a life-threatening illness. Then the First World War began. Fleming served as a medical officer in the Royal Army Medical Corps and worked with wounded soldiers in France. He saw men arrive with terrible injuries. Some wounds were deep and dirty. Dirt, bacteria, and damaged tissue created perfect conditions for infection. Fleming watched doctors fight these infections with the treatments available at the time. He became concerned about the way some antiseptics were used. They could kill bacteria on the surface of a wound, but they could also damage healthy cells and tissues. In deep wounds, they were not always effective. Fleming believed medicine needed something better. After the war, he returned to St. Mary's and continued his research. He studied bacteria. He tested substances. He made observations. And he kept looking for ways to stop harmful microorganisms. Then came that September morning in 1928. The contaminated dish. The strange mold. The clear area around it. Fleming began testing the mold. He identified it as belonging to the genus Penicillium. He named the antibacterial substance it produced penicillin. The idea was simple. The mold was producing something that could stop certain bacteria from growing. But turning that discovery into a medicine was anything but simple. Fleming tested penicillin against different bacteria. The results were promising. It could act against several harmful bacteria. And unlike many harsh antiseptics, it appeared much less damaging to human tissues. This was important. But there was a serious problem. Fleming could not produce large amounts of penicillin. The substance was unstable. It was difficult to extract. It was difficult to purify. And it was difficult to store. Fleming published his findings in 1929. The scientific community had the information. But penicillin did not immediately become a common treatment. For years, Fleming's discovery remained largely undeveloped. The story might have ended there. But more than 10 years later, another group of scientists returned to the problem. At the University of Oxford, Howard Florey and Ernst Boris Chain became deeply interested in Fleming's work. Their team included Norman Heatley, who helped solve many of the practical problems involved in producing and extracting penicillin. They knew the substance could be useful. Now they had to find a way to make enough of it. The work was difficult. They grew the mold. They collected the liquid in which it grew. They developed methods to extract the penicillin. They purified it. Then they tested it. In 1940, the Oxford team carried out an important experiment with mice. The mice were infected with dangerous bacteria. Some received penicillin. Others did not. The results were striking. The untreated mice became seriously ill. The mice that received penicillin survived. The experiment gave the scientists strong evidence that penicillin could work inside a living animal. Now came the next question. Could it save a human life? In 1941, doctors treated a British police constable named Albert Alexander, who had developed a severe infection. At first, the treatment seemed to work. His condition improved. But there was not enough penicillin. The supply ran out. His infection returned. Eventually, he died. It was a heartbreaking result. But it also proved something important. Penicillin could help. The problem was not whether it worked. The problem was producing enough. And the world was about to enter a period when that problem became urgent. The Second World War was raging. Thousands of soldiers were being wounded. Infections were killing people who might otherwise have survived their injuries. Scientists and pharmaceutical companies in Britain and the United States began working to produce penicillin on a much larger scale. Researchers searched for stronger strains of the mold. They improved the way the mold was grown. They developed larger fermentation systems. They found better methods for extracting the drug. Slowly, laboratory production became industrial production. Penicillin was no longer just a strange substance found in a contaminated petri dish. It was becoming a medicine. By the middle of the 1940s, large quantities were available. Doctors began using penicillin to treat serious bacterial infections. The results were extraordinary for the medicine of the time. Illnesses that had once been extremely dangerous could now often be treated. Wounded soldiers had a better chance of surviving infection. Patients with certain forms of pneumonia, blood infections, and other bacterial diseases had a new weapon. And medicine entered a new age. In 1945, Alexander Fleming, Howard Florey, and Ernst Boris Chain received the Nobel Prize in Physiology or Medicine for their work on penicillin. Fleming was now internationally known. But there was something important about the way his story was remembered. People often called penicillin an accidental discovery. That is partly true. The mold appeared by accident. Fleming did not plan to create penicillin that morning. But the discovery itself was not simply luck. The important moment came when Fleming noticed something unusual and decided to investigate. A contaminated dish was not the discovery. The observation was. The question was. The experiment was. And later, the work of Florey, Chain, Heatley, and many other researchers turned the observation into a practical treatment. That distinction matters. Science often depends on unexpected events. But unexpected events do not automatically become discoveries. Someone has to notice them. Someone has to ask why. Someone has to test the idea. And someone has to keep working when the first answer is not enough. Fleming understood this. He also understood that antibiotics were not magic. Bacteria could change. If antibiotics were used incorrectly or in insufficient amounts, resistant bacteria could survive. Those bacteria could multiply and spread. Over time, this could make antibiotics less effective. Fleming warned about this problem long before antibiotic resistance became the global challenge it is today. His warning showed that he understood something basic about nature. Life adapts. A treatment that works today may become less effective tomorrow if we use it carelessly. That is why antibiotics must be used properly. Fleming continued working in medicine and research for the rest of his life. He became a symbol of scientific observation, but his real legacy was larger than one person. Penicillin was the result of many people working across different places and different years. Fleming discovered the antibacterial effect. Florey and Chain helped develop it into a usable treatment. Heatley helped solve difficult technical problems. Scientists improved production. Pharmaceutical workers manufactured it. Doctors tested and used it. And millions of patients benefited. This is how major scientific progress often happens. One person sees something. Another person develops the idea. Someone else solves a technical problem. Others make it practical. And eventually, the discovery reaches the people who need it. The most remarkable part of Fleming's story is how ordinary the beginning was. There was no dramatic explosion. No giant machine. No moment when Fleming immediately knew that he had changed medicine. There was only a laboratory. A few petri dishes. A holiday. A forgotten experiment. And a patch of mold. Fleming could have walked past it. He could have thrown the dish away. Instead, he looked again. That small decision mattered. Today, antibiotics are part of modern medicine. They are used to treat many bacterial infections and have made countless medical procedures safer. But antibiotics do not work against viruses, and they must be used carefully. The fight against bacterial disease continues. Scientists still search for new antibiotics. They study resistant bacteria. They develop new treatments. They look for better ways to prevent infections. And the basic habit that helped Fleming remains just as important. Look closely. Question what seems strange. Test what you find. Learn from mistakes. And never assume that an unexpected result is useless. Alexander Fleming did not set out that morning to change the world. He was simply doing his work. Then he noticed something that did not make sense. A mold had appeared. Around it, the bacteria were gone. That tiny clear circle became one of the most important clues in medical history. And perhaps that is the most powerful part of the story. The discovery of penicillin did not begin with a grand plan. It began with curiosity. A scientist saw something unexpected. Instead of ignoring it, he asked one simple question. Why? And sometimes, one question is enough to change the course of history.